Hello, and welcome to Unplugged Computer Science Activities. My name is Elisa Whitcliffe, and this is...
I'm Chris Gordon.
And I'm at UNC Charlotte, and Chris is at...
Lenore University.
So today we're going to have some activities for you, and we're glad that you're here. This is really for novice or new teachers to computer science, and we have some fun activities that we use as introduction to computer science. And most recently, North Carolina, the Department of Public Instruction has been developing computer science standards, and these are going to be released very soon, if they haven't already. And Chris is going to go over the main categories.
So they have computer systems, and they have networks and the internet, data analysis, and algorithms and programming, and impacts of coding. So it's not just coding that we're talking about. We're talking about the entire process behind coding.
And this is K-12, so there are standards for every grade.
And the activities we're going to do today do not require a computer, but they do involve algorithmic thinking and some programming. So that brings us to our next slide, what are unplugged activities? Unplugged activities are computer science activities that do not require a computer. Most people think to do computer science you must have a computer, whereas in fact computer science was developed way before computers.
And so our four activities are counting in binary, my robotic friend, coding decoding wheel, and we're just going to describe some board games that you might use in your classroom.
So for our first activity, it's called counting in binary. This comes right from the CS Unplugged website. This is a fantastic resource. If you've never used it, please check it out. This one comes from their classic CS Unplugged, and here's a link that will get you directly there. Activity is counting in binary, and binary information is stored in individual bits. 8 bits make up a byte. Each one of these represent 1 bit of information, and a bit is either on or off. And that's how the computer knows. So if they're all off, this number will be 0, 0, 0, 0. So the number 1 would be 1, 0, 0, 0. The number 2 is 0, 1, 0, 0. The number 3 is 1, 1, 0, 0. The number 4 is 0, 0, 1, 0. The number 5, 1, 0, 1, 0. The number 6, 0, 1, 1, 0. The number 7, 1, 1, 1, 0. The number 8, 0, 0, 0, 1. Number 9, 1, 0, 0, 1. Number 10, 0, 1, 0, 1. The number 11, 1, 1, 0, 1. The number 12, 0, 0, 1, 1. 13, 1, 0, 1, 1. And the number 14, that's 15, 0, 1, 1, 1. And the number 15 is 1, 1, 1, 1. And we can add another couple numbers over here, and it would, we can get many, many numbers. Now, this is something you could do with a whole class where you could have students doing this, but you'd also have students make their own individual sets of cards. And you could lay them out on the table, and the students could count in binary by flipping them over. And so there's 1, 0, 0, 0, 0. Then that's the number 1. The number 2 is 0, 1, 0, 0. So these are something really inexpensive you can make. The students can make their own, and you can give them to them. They can take them home and impress their friends with their ability to count in binary. And a additional activity you can do with binary is you can look at talking about letters. And there are sheets like this. You can print them out from a lot of places, and it has the binary letters, and students can make a bracelet that represents their name. So this is, it starts from this end, and if you look at the letters, there are 8 bits in a byte. Remember we talked about that earlier? So 8 beads are a letter. So 1, 2, 3, 4, 5, 6, 7, 8. So this is the letter I, and this bracelet says Ian. And this bracelet is for a longer name. This bracelet is for Chris. And if you count the beads, there's 8 beads for each letter in his name, and this is Mikey. So this is Mikey's name. And so the students can make these, and what I would do is I would put a bead at the beginning so they know where it starts, and then they can make a bracelet or a necklace that they can wear that has their name on it.
And these, the ASCII code, it actually helps, it allows the computer to translate numbers, 0 and 1s, into letters. And so this is the American Standard Code for Information Interchange, ASCII. And you can see here the A, what the pattern looks like, and what it starts with, and the last, all of the 8 bytes bits to make a byte, right?
Yep. Yeah, so this is a fun activity, and this is something you could do on a rain day. And so for our beads, we've chose light and dark colors. So light color would be the on, and the dark color would be the off. And that's something that you can do with pony beads. Woo! That one broke. So Ian, sorry. But that's okay. It's a short name. You can redo it. So that's a fun activity you can do. You can do this on a rain day. You could do this as a independent work table. You could have the key laid out. They can make their bracelet or set out each letter, and then you can come check, and then they could or check each other, and then they could assemble their bracelet and take it home with them. The next activity is called My Robotic Friend. And for this activity, it comes from CS Ed Week, Computer Science Education Week. And here is a link to that. It's a fantastic activity that allows people to work together in small groups or individually to do the activity. And the second link is a video that demonstrates it relatively nicely, almost as good as our demonstration.
Right. And this activity you can enrich. You can add more to it, and it'll be clear when you see the activity. And additionally, it's similar to a technical writing, write it, do it activity in Science Olympiad, but this is actually around computer science.
This activity is called My Robotic Friend. The instructions on the website are really good, but I'm just going to preview them. This is a nice activity because you can use your index cards that you probably have tens of thousands of them laying around your classroom. So what I'm going to do is I'm going to write a secret code to make a design of these cups, and I'm going to give it to my friend who's a robot who can only read the code that I write. So if I wanted to make the cups move, the first thing I have to do is pick a cup up. So I'm going to start with an up arrow. You can't see that. That's fine. So I'm going to go up. And the way My Robotic Friend works is each arrow to the right makes it go over half a cup. So I'm going to go over 2 arrows, which give me 1 full cup, and then I'm going to put the cup down. Then I'm going to pick the cup up. I'm going to go over 1, 2. If I put it down, it would go right over this cup, which I don't want. So I'm going to draw my 2 arrows. And then I'm going to go over 2 more arrows to get me here. And then I'm going to go down. And this is what my code looks like. Okay. And then for my third cup, I'm going to pick it up. I'm going to go over 1, 2, 3 times, and then down. Over 1, 2, 3 times, and then down. So this is what my final code looks like. Show them. You can see it. Okay, so now I'm going to give my secret code to My Robotic Friend, and they are going to try to reproduce what I've done. It's a nice quiet robot. It doesn't make any noise. And what's nice about this is each line represents an individual cup. And you can put things in there like to rotate the cup, so you can have your final look like this. You can have it sit on its side like this. You can do a lot of things. In fact, if you want to really trick someone, you can double stack the cups because they never expect that. So this is called My Robotic Friend. The next activity is called Decoding Coding Wheel. These are very similar to the things you probably made as a kid, and where you can print these templates out. This will take you to a template maker where you can make wheels of all sizes with all kinds of different increments. And the kids can use these to make a decoder wheel. The way I've used it is that I start with my real code on the outside wheel, and then I transfer to the inside wheel to make a gibberish code that the other person has to figure out. And then when they get it, they start on the inside wheel and move the letters to the outside wheel.
And coding and decoding, it's actually part of encryption, and encryption is part of safety and security around our computers and our use of computerware. And so this is an introductory activity to have the students start thinking about encryption for safety and security.
And for young kids, you don't have to make a wheel this complex. You could have like square, circle, triangle, shapes that they're trying to learn on each of the wheels. They could spin it, and then you could have them line their code out with blocks and 3D physical objects that they have. This link will take you to the Kids Museum. It is a really good video that shows this in use. Plus, at this link, they have a whole bunch of other activities related to hands-on coding that you could do with your students.
And this actual wheel is just made with paper, colored paper, and it has a brad in the middle, so it's not costly at all.
Yes. Cardstock is preferable, but you can just use regular paper. And we have 2 different colors, and you don't even need 2 different colors. But if you have 2, that's the best way to go. So this activity is called the Secret Coding Wheel. And probably a lot of you guys made these when you were younger. And I know that I used to play with these all the time when I was a kid. There are several ways you can make this. There are templates in the PowerPoint that will direct you to where you can download templates. So this one here, I've got an inner wheel and an outer wheel, but also on the outer wheel, you can't hardly see it, but there's numbers inside there. So the way this is set up is we can select a day. So I'm going to choose November 11th in honor of Veterans Day. So I'm going to set my secret coder wheel to 11. Then I take my secret message and I find the letters on the outside wheel and go to the inside wheel. So I'm going to write my secret message. And now, somewhere across the country, my partner in crime has a similar wheel that they made, and they know that, here's my secret message, they know that we are honoring veterans, so they're going to set their wheel to November 11th in honor of veterans, and they're going to take the message. I went from the big wheel to the little wheel, so now they're going to find the letters on the little wheel, come out to the big wheel, to decipher the message.
So R is S. And S is T. S is T. And D is E. D is E. And L, little wheel to big wheel, is M. STEM.
And that was, in fact, my secret word, so our coding wheel works perfectly. So, lots of fun. Please make one with your kids. This is 2 of my favorite board games that teach coding. This first one is Codemaster. I bought this for myself for Christmas last year and spent the entire Christmas break going through them, trying to solve all the coding puzzles. There were 4 puzzles that I could not solve. So this goes everywhere from very simple, a second or third grader could do them, all the way to where I've been coding for 10 plus years and I couldn't solve all of them. It's a very fun, active game. You can play individually or you can play in groups. The way I would use this with groups is I would have one person gather the materials that you need for each round, one person code, and one person be the beta tester to test the code to make sure it works. Then students can rotate jobs as they go through the different puzzles and mazes. I think there are 80 mazes in there that you have to try to figure out. It's a lot of fun. The kids that I've seen play it, they really like playing it. It's very, very entertaining and engaging. The second game is My Robotic Turtles, or Robotic Turtles. It's not quite as much fun, but it is still a pretty good game. If you go to these websites, you can get more information on this. The Codemaster comes from Think Fun. If you go to their website, they have a bunch of really engaging games that you can select. And they do have other coding games that you can select from as well. Here's some additional places where you can get information that will help. Beyond Our Code has a lot of activities that are both plugged and unplugged that you can use in your class. Girls Who Code have a lot of good information. You could, between these two websites, you would have easily a year's worth of material you could teach your kids. Hello World Magazine is a computer science magazine set up by the Raspberry Pi Foundation that's specifically geared toward teachers. This magazine is nice because they have a whole bunch of classroom tested activities in there, and they go from easy to difficult activities almost in every single magazine. Plus, it's a free download.
And the Family Code of Night, you can actually click on there and you can find an event near you. They advertise the events, and they usually hold that in conjunction, and communities invited. So parents and other people in your community are invited to participate for Family Code Night. I like this graphic. The computational thinkers. It really defines it well. It has concepts on the left and approaches on the right. We're all computational thinkers here. And, the approaches are tinkering, creating, debugging, persevering, collaborating. The concepts, logic, evaluation, algorithms, patterns, decomposition, and abstraction. So these are the base skills for computer science, for the standards, and for your students.
And just with these activities that we did today, we've seen some logic, we've seen a lot of tinkering and creating and debugging, and some persevering. You guys seen the final cut of some of our activities, but there were a couple of them activities we had to do 2 or 3 times. And every single one we had to decompose our complex task and make it simpler for the computer to understand. And we also did a lot of patterns.
And we collaborated.
Yes. So just in these 4 activities or 3 activities that we did, we hit a lot of these standards. So once again, this demonstrates that you do not need a computer to teach computer science. All you need is a willingness.
So there's an evaluation. This is the link. I think you'll be sent that as well. And our contact information is here. Again, I'm at UNC Charlotte, and Chris is at Lenore Ryan University. And we'd be happy to share other activities that we've used. And we hope that this was helpful to you. And we wish you well with your computers.
Good luck.
Unplugged.
And have fun doing
Computer science.
unplugged computer science activities with your students.